Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Space Cargo Unlimited is a European startup dedicated to leveraging the potential of space microgravity research for commercial applications on Earth. The company is developing Rev1, the first orbital manufacturing facility. And my guest is Nicolas Gaume, co-founder and CEO of Space Cargo Unlimited. And Nicolas, welcome back to the podcast. We had you on once before talking about another issue, which we're going to get a follow-up on here in a little bit. But it's always great to see you. Thanks again for coming back on.
Thanks so much for having me, Tom. Great to be here.
For those of the folks who are listening or watching who might not have met you the first time around, tell us just a little bit about Space Cargo Unlimited and what it is you do.
So Space Cargo Unlimited is an 8-year-old European startup, and we really were completely created and founded with my partner, Emmanuel Echepar, with the intent of making space manufacturing become a real thing. It's been researched extensively for the past 30 years, particularly in the most recent decades on the International Space Station. And the impact on life science, on new materials and agriculture provides so many exciting opportunities. We really wanted to make them accessible to both company involved in manufacturing on Earth, as much as obviously the general public for providing all the benefits of increased high-value product.
Tell me a little bit about your background and how you got involved in space and the environment and space manufacturing and the many of the other things that you're involved in this industry.
Yeah. So I'm primarily a tech entrepreneur. I had actually 9 different startups. I started in video games when I was 18, so a long time ago. I explored a lot of digital related projects and web, media, mobile, social networks, and really always had a passion for space. And as things became, let's say, more accessible with cost of infrastructure going down, launch costs going down, we felt it was the moment to create Space Cargo Unlimited. And, I think that when you get older, you really want to have more impact. And as I said, the research on the space station primarily has shown so many high value potential. We really wanted to be the one that could make creative decision and hopefully grounded decision to make that become a reality for most of us on Earth.
Now, speaking of that research you've just conducted on the International Space Station, you did have a successful mission over the course of the past year, and it involved one of my favorite subjects, which is wine. And I understand the wine came back, and just give us an update on how the characteristics of the wine changed after having been aged on the space station.
To put, if you allow me, Tom, to put things in context for those of your listeners that we didn't have a chance to follow what we did. So we did a pilot mission on agriculture, and we decided to focus on the particular topic of viticulture with the intent of learning and pretty much bringing what we would learn in viticulture to other areas of agriculture. Just want to say that for context. Now, viticulture is interesting because it's quite a lucrative agricultural segment, which means they are highly skilled and great research infrastructure we could leverage. And as you really go into the unknown, it's good to start with really solid basis. We obviously also have a passion for wine, and wine also had a lot of interesting history when it comes to life science. You may know that the French scientist Louis Pasteur actually studied wine for 8 years, and that's where he actually identified bacteria, which arguably defined a lot of things in today's modern life science. He also invited pasteurization, the process of keeping things eatable for wine. Didn't work out that well for wine, but he actually applied it to dairy products, and there you go. So wine is a key component of some of the historical research, and it's interesting because there's a lot of it's a multi-component liquid with a lot of key components: bacteria, yeast, polyphenol. And so studying wine was a fantastic study materials to better understand life on Earth, and still a lot of key things related to life science and, of course, wine itself. So the wine, to answer your questions, was different. We will be publishing a paper, hopefully this winter, spring, depending the peer review time, which is not an exact science itself. But we have actually identified some very exciting differentiation. But to the tasting itself, the wine was quite similar to the nose, a little more brick color to the eye. And when you drank it, it was much more floral. Now, evaluation and tasting was different from, different tasters, but it was all up seen as different, perceived as different for pretty much the entire people who had a chance to drink both the Earth and space wine. So quite exciting outcome. Just for the record, we also launched, we launched these bottles on the space station for 14 months. Mm-hmm. And as I said, we'll be publishing the outcomes of our research next year, let's say. We also brought to the space station 320 vine plants, Merlot and Cabernet Sauvignon, which evolved differently after the exposure to the space environment, which was really what we are intended to capture. And there too, we'll continue to publish our research. We already published some of it. We had a very good conference in Houston in November explaining the detail of outcomes. And in a nutshell, these variety of plants we exposed to space evolved differently than their initial twins on Earth, which was in itself super exciting. And then even more exciting, the space plant showed very exciting resilience capacity against some of the climate change related challenges from hydrate test, temperature stresses, and along with some disease like mildew specifically, which is a disease that is very lethal to agriculture and to vine plants. So very excited about that research and very excited about the progress. We also had a third launch we did with Blue Origin suborbital, where we put some of these vine plant cells exposed to the climate change stresses I was referring to, that allowed us to do a better experiment on our third flight with the ISS. But all these three flights showed us, the inside of what it is to be a lab or a company willing to capture the space opportunity to make high-value product on Earth, high-value product that you wouldn't be able to or you hardly be able to manufacture on Earth. And that's really what led to eventually work on this project. We're here to talk about Rev1.
And that's a perfect segue, because that's what caught my interest when I saw a news release about Rev1. It's a partnership with, I believe it's Thales. Is that how you pronounce that? Thales Alenia Space?
Yes, Thales Alenia Space, which is a large European space manufacturing company. They build satellites, but also building a lot of exciting components. They actually roughly manufactured half of the ISS, including the cupola, which is this great window on Earth for all astronauts. Axiom is outsourcing a lot of their work of their new modules to Thales Alenia Space, and vehicles like the Cygnus from Northrop Grumman is also mainly made in this same factory we'll be using, based in Torino in the northern part of Italy. So that's an exciting partner who actually was also involved in our wine mission, because they, in partnership with NanoRacks, they built the canister where we put our bottles of wine into. So it's a long-lasting partnership that is becoming a very big partnership for them as much as for us.
So what is Rev1?
So Rev1 is really effectively a pressurized space vehicle that is going to fly 2 months in low Earth orbit. Aboard the vehicle will be a manufacturing device that will be addressing a variety of opportunities, from life science bioreactor to cultivate some stem cells to 3D printing units that will manufacture new materials. Again, all of them seizing the particular condition of the space environment. And the idea is to be a factory. So basically we'll have clients chartering us for flying their production units and flying them back to Earth with their produced materials or research. So that's a very simple flying factory, simple to describe, harder to build, but a flying factory with a 2-month average mission in space.
So give me an idea of about the approximate size that Rev1 is going to be. I mean, can you compare it to a space shuttle or to the XB-37? Kind of what are we looking at?
So we're actually using an existing vehicle to start the work. So European Space Agency and the Italian Space Agency have been working on a vehicle called IXV, which actually flew now 8 years ago, and now working on an enhanced edition named Space Rider. And so both these vehicles have been really empowering Thales Alenia Space to begin with, to build and certify key components key components of the vehicle all up, which we're going to leverage for our own design. And that's what make it quite exciting for us to work with them. So it's roughly, to give you a size, and I'm trying to convert my meters into feet to make sure I'm not getting lost, but it's about 15 feet long.
Okay.
Just so you see the size, it's about 1 ton pressurized space cargo, and it's about 1,200 liters in terms of volume of the pressurized cargo.
So what kind of manufacturing can be done in that space? Because people think about a factory and they think about big sprawling acres and acres and acres of heavy machinery. What do you do in that size and space?
So we're going to primarily focus on 2 areas, life science and new materials. And really, we're going to look into reasonably sized hardware equipment, similar to the one you can see on the ISS. So think about a 3D printer, so it's really a unit that is the size of a big printer, roughly. All automated. That's one of the characteristics that is super important, because research on the ISS is done with humans. Astronauts conduct experiments all throughout the day, and without them, we wouldn't have the quality of research that we have. Now, when it comes to scaling and manufacturing, the humans that are so powerfully empowering research become an obstacle, because safety is of paramount importance. And if you manufacture a cable, or if you grow plants, fairness, you wouldn't want to compromise the life of an astronaut to the detriment. So sure. we want to make sure, we remove that choice and focus solely on manufacturing. Obviously, human safety also increased the cost significantly of any vehicle. So as we see space station being replaced by private space station, we're really excited about how this will continue to push the research further. But to really go into scaling manufacturing, a fully automated vehicle is really the only viable option, we think. And we're building this vehicle in a very inside-out perspective. So we're really starting with the payload and what we need to make successful manufacturing campaign to manufacture, meters, inches, and feet of a fiber optics, and you need a 3D printers, and you can build this fiber optic named Zipline. It's quite well known for anybody looking at in-space manufacturing. Zipline is actually a fiber that was invented by a French company. It's based on fluor instead of the typical silicium that you have for a normal fiber optic. And when you use it with certain frequency, it's so much more conductive. So it's actually used with laser comms and a number of specific manufacturing or military usage. And this fiber is called exotic fiber, is extremely valuable and pretty much impossible to really create or manufacture on Earth at a large length. So building a 3D printer, there's a number of units that have been tested by a number of great companies, many in the US, into space. You can actually manufacture, again, very valuable payload in space for 2 months. Life science is really where it gets us most excited. We have a lot of opportunity to build specific high-value research materials. When you look at proteins, for looking at new medication, you need to crystallize proteins to study them. And the protein crystals in space are bigger, more rounder, and easier to analyze to find potential cure or new medication processes. So, protein crystallization is something you can do in a small unit that is, again, the same size of a. I'll keep the printer as a reference. Everybody has a printer at home. Sure. That give you a sense of the size of it. And so all these various payloads will be one to next each other. We haven't disclosed the unicity of the way we establish our payload infrastructure, but it is pretty unique, pretty innovative, I believe, and it will provide all the necessary power, heat management, as much as really a very stable environment. Our vehicle is really geared towards a very sensitive payload, to accommodate sensitive payload by being able to have late payload as designed, as much as early retrieval when back on Earth with very smooth landing. So we will also want to make sure we pay close attention to the quality of what it is we provide our customer with. So again, multi-purpose vehicle focus on in-space manufacturing.
I'm talking with Nicolas Gaume, co-founder and CEO of Space Cargo Unlimited on the Ex Terra Podcast. Take a moment right now to click on subscribe to make sure you don't miss any of our podcasts, or if you're watching on YouTube, any of the videos from Ex Terra, the Journal of Space Commerce. Nicolas, I'm getting the sense from the description that you're giving me of the Rev-1 vehicle that it's kind of reminiscent of the Sierra Space Dream Chaser. It'll launch vertically, recover horizontally, and be a completely reusable vehicle. Is that a pretty good assessment?
Yes, I mean, we estimate that, well, actually, Morgan Stanley estimate that the business of in-space manufacturing will be roughly 20 billion by 2040. We believe it will be actually bigger sooner. So there's no doubt that a lot of vehicle will be able to seize that opportunity. So first of all, there are a number of great companies in the US, in the UK, and worldwide raising fund to seize that potential. As for the vehicle itself, yes, as I said, we're similar to Sierra Nevada vehicle and any other principle that is like a shuttle style, flying on the top of a rocket, flying back home. We using an existing vehicle, as I said, IXV and Space Rider. So we were not really innovative in the way that we designed the vehicle. We've been very innovative in the way we, again, accommodate the payload infrastructure and the entire really manufacturing setup, which is really our core competence. That's also why, by the way, we teamed up with Thales Alenia Space with a great background and with a very unique partnership between a small startup and a large organization. I think we make something that provide a very viable business case while providing the robustness of a top-notch space manufacturing company worldwide, and the agility and let's say the creativeness, especially when it comes to go-to-market, that I think we demonstrated in the past.
Now, your plan is to get Rev-1 into orbit in 2025. What kind of lifetime are you expecting on the vehicle? Are you looking at a fleet of them? How many times can they be reused? What are some of those details?
So we do plan to have a fleet of vehicle. It has to depend on the success of our business, of course.
Sure.
But we're confident enough to consider a fleet of vehicle. We're targeting at 20 reusable, so 20 flights per vehicle. And the idea is to have 1 to 2 flights per year for each vehicle. So, you establish anywhere between 5 to 10 years for a vehicle. Now, having said that, we hope to be able to also refurnish this vehicle in an effective manner and extend the lifetime. So we will be looking at how things go when we start operating. But that's the goal.
You're obviously talking about an unmanned and autonomous system. What kinds of technologies are already available, and what do you still need to develop to be able to conduct these kinds of experiments in space without having any human intervention?
So, I have other lives besides Space Cargo Limited, and one of them is I'm very fortunate to work at Microsoft and lead the space activities of Microsoft, partnerships and global expansion. And it happens that Microsoft has a lot of exciting technology. For instance, others exist. I think Microsoft is the best one, but others exist when it comes to digital twin or IoT sensors and remote control. And so we definitely will leverage this existing technology that is available out there and the power of Azure cloud computing to kind of sustain our work and be able to be fully in control of the manufacturing units and the vehicle itself while in flight. So we're very excited about what this technology can provide. More globally, I think that when you look at it, there's a lot of exciting components of our vision that's becoming very available, very affordable. Well, let's say very affordable. Let's say much more affordable than used to be. So we talked about leveraging an existing vehicle with IXV and Space Rider to build Rev-1. Talked about what Microsoft is developing in terms of control, in terms of processing, in terms of remote management and all the technology stack from, again, the cloud itself, Azure, to the IoT setup. So, as we move forward, we look at aggregating all these technology to make something fairly unique. A lot of engineers start with this NIH syndrome, not invented here. I need to reinvent everything to make it great. We are much more humble, and we'll go to the SWP approach, which is stolen with pride. In all fairness, we're not stealing, we're buying. But we feel that, we should really be a fabless, very focused on in-space manufacturing organization, try to look what works best. And I've been managing startups. I'm a developer, software developer to begin with, but I've always been interested in analyzing how things work, optimize, look at the short optimization paths for success. And what we're doing really is looking at constantly everything with a reusability angle, testable angle, with an effectiveness angle. And it's quite different from the more traditional government program where everything needs to be perfect and over tested, therefore sometimes over engineered, and have cost of operation that are really get out of control. We're very much looking for optimization. I started hacking software. I started, coding in assembly language. So I love this notion of using every byte of memory in an effective manner. And it grew on me as I go older. So all our team culture is really around if we do something, it has to be fully effective and fully effective for the purpose of what we're doing it for. And that's really the spirit of what we're building here.
You said Rev 1 is based on an existing spacecraft design. What about the launch system? Will it be compatible with any launch system? Do you have something proprietary? That's kind of my last operational detail I want to get out of you.
No, it's an important detail. We really designed the vehicle to be absolutely compatible with a large variety of launchers, and we'd like to make sure we are able to fly with any of these launch. And there are quite a few being developed worldwide. Because European, there's a number of European solutions that are kind of obvious. Vega C from Avio is flying IXV and Space Rider. It's a great Italian and European rocket manufacturing company, which we're engaged with to discuss the launch options. There are other great options we'll be unveiling next year, which is this year, if I guess this.
by the time folks see and hear this, yeah.
Yes. And so, and we're very excited. I mean, I'm personally quite excited by a number of launch solutions. I'm eagerly waiting for Relativity to launch their rocket. I'm a huge fan of SpaceX, like a lot of us. So, I'm looking at all the options, obviously looking at Blue Origin and many, many others. So we'll be looking at what works best for this vehicle and obviously what's bring the best cost to optimize our full services to our customers.
I want to take a minute and talk just a little bit about Orbite because I wanted to get just a quick update on how that project is going. It's your astronaut training program that I know you're setting up in different places around the world. So what's the update on Orbite and how far along have you come along with that?
So Orbite is a company I co-founded with Jason Andrews, with a well-known space entrepreneur who was behind Black Sky, Leo Stella, or Spaceflight. He's a dear friend, a wonderful partner. He's the CEO of Orbite. But we really, both him and I, realized that as you saw, amazing company like SpaceX, like Blue Origin, like Axiom, like Virgin Galactic, and others working on providing commercial human spaceflight opportunities, we felt there was quite a lack of service, of training infrastructure. There's a lot of great training entities around the country and internationally, so don't get me wrong, but we didn't think there was one cohesive place to train campus with the right level of service and quality with a very people-centric approach. So it happens that I actually own a hotel and a restaurant in the southwest of France. It's a boutique hotel, one of very successful boutique hotel that my actually great-granddad built. My granddad managed, and my father and mother managed. So I kind of was born as an hotelier and really did every single job in a hotel and restaurant. So I guess that's part of my DNA. And, again, looking at the way that most of the great spaceports of America are surrounded by, let's say, affordable hotels and not always very, again, unified and scattered training centers, we thought it would be a great way to build something of the highest quality. So we hired Philippe Stark, which is a very well-known hotel designer, and started working on this in parallel of securing an amazing place, which we haven't disclosed yet in the United States, and starting our own trainings, which we did in Florida, nearby Cape Canaveral, as much as in the southwest of France, where my hotel is, but also where is the headquarters for the French Space Agency, where all the zero-G flight from Europe, train the European Space Agency flight from. So we could really benefit from this infrastructure, test the variety of the space training experiences we are excited to provide to the large public. And I've been really very fortunate to have an amazing success with demand. So as we refine our offering with a great team, we are eagerly waiting for next year, where we'll be announcing, next year being this year, 2023, announcing where our location for this campus will be. But really moving great. and they're very excited about this project.
Look out, if you will, Nicolas, and I know we asked you this last time, and maybe your answer's changed, maybe it hasn't, but just kind of give us a forecast over the next 10 to 15 years of kind of what you see coming in the realm of space commerce.
Well, I even though I'm fortunate to work at Microsoft on the Azure Space solution, even though I'm fortunate to be the co-founder and CEO of Space Cargo, even though I'm co-founder and executive chairman of Orbite, I really consider myself still as a newbie in space. So I really humbly look at the great leaders of this industry and the great designers, engineers that are forging the future. But I think, when it comes to my own take, and I think it's more philosophical, I think that I can see a great divide between escapists and Earth lovers. You can argue you can be both. I believe you can't be both easily. And I really look at space as a great opportunity for Earth. I look at space for a great opportunity to invent the product that we will need on Earth for tomorrow, to have a enjoyable, sustainable life, despite the challenges that humanity is imposing on Earth. That's what Space Cargo is all about. I truly believe that all the people that will be fortunate, still very expensive, but it become more and more accessible to fly into space. And I think that as we move forward and bring more humanity into space, it should be first and foremost for all the people staying on Earth that won't benefit from this overview effect as much as all the resources we'll be able to capture in space for Earth. I'm a big believer in, obviously, planetary resources coming from, rare materials that we will have a hard time, extracting from Earth moving forward, that we'll be able to find plenty in various celestial bodies. And so I really tend to believe that space is super important for the future Earth, but it's all about Earth and humanity on Earth. And certainly the infrastructure that is being built, the amazing revolution that Starship represents, the great plans that NASA is supporting with great stations, what China is doing, all this contributes to a future man in space, which I think is a very exciting opportunity for all of us on Earth.
So what does the ability to manufacture in space do for that overall space economy? What is that benefit that you're hoping to bring to your customers?
So as I said, stem cells develop 10 times faster in space than they do on Earth. But you could think of many different applications. Tomorrow, someone will be burned to badly on Earth, will be able to grow its own skin into space and really retrieve good health, where today it's really not possible. You'll be able to, we're working with, I had a discussion, let's put it that way, with Genathon, which is one of the very specific genetic research company working on rare disease and doing some very specific DNA treatment based, which look at the space environment as a unique environment to create the next generation of medication they work for. And they cost a ton of money on Earth. They could really bring down the cost significantly down with the space environment. You look at new materials. When you merge two new materials on Earth, the heavier one goes down, the lighter one goes up because of gravity. Imagine you remove gravity, you can do perfect alloys. If you go into the very tiny little miniaturization, if you look at optical length are really super hard at the small, tiny length level to be able to make them perfect. So space will allow you to do that, whereas on Earth, you'll have to do a lot of work to get there. Computer electronics, you need to have perfect white rooms if you go to a very small computer microprocessor and go to the smallest possible. Well, space provide a natural white room, so you can leverage that. And when you start looking into all the opportunities, you realize that the change of status from liquid to solid to gas is a very interesting moment to capture unique opportunities. On our plants, we realized that what evolved most in the plants were bacteria, the biome surrounding our plants, and realized that we now have a very interesting solution for a lot of agricultural product we're working on. So as I said, it's mind-blowing the amount of opportunities you can seize in space for Earth. And that's what Rev1 is all about, unleashing that opportunity for labs, for small, medium businesses and larger companies to seize that manufacturing potential. And it's still way too expensive. More importantly, it's very unpredictable. Today, the space station provides unique opportunity. And I think, honestly, NASA is doing such a phenomenal work, like they did for our wine and vine plants. But it's still very much depending on a lot of political constructs, because when you exploring Mars or the moon, you need to do a human spaceflight experiment. It's going to be prioritized among your plans, and you'll be bumped to the next flight and so on, which is perfectly normal and understandable. But if you want to go at scale and become more commercial, you need reliability. You need to have predictable launch date. You need to have predictable outcomes that you can work on and monitor during the flight. Again, all this we think we can provide and bring the opportunity further and becoming more real for Earth.
You talk about getting off Earth. Would you go? Because when I bought my lottery ticket back when it was $1 billion, I said if I win, I'm going to space.
I definitely love the opportunity, and I think that it will become sooner than you think. Now it's certainly very exciting to see all the great work being done. So I definitely want to go.
Well, you may make it. I'm probably too old at this point, but I'll wish you good luck. And
look, William Shatner, come on! You still
there's that. Okay, Bill went at 90. Maybe I've got a shot. Nicolas, we're out of time. Thank you so much. It's always a pleasure to talk to you.
Thank you, Tom.
It's been great to just catch up a little bit.
Thank you so much, Tom, for having me.
Nicolas Gaume is co-founder and CEO of Space Cargo Unlimited. And that's going to do it for this edition of the Ex Terra Podcast. You can subscribe to the audio version of the podcast on Spotify, Apple Podcasts, and many other popular podcasting platforms. Be sure to click on subscribe so you don't miss an episode of the podcast or any of our other videos. And you can also get daily space commerce news at xterrajsc.com. And one thing more, be sure to connect with us on LinkedIn and follow us on Twitter at xterrajsc. Until next time, I'm Tom Patton. Thanks for joining us.
I wanna go faster, faster. Hands in the air, we're gonna crash. Searching for the answers like Galileo through his looking glass. That's for reason. Our dreamer's eyes we gaze into a sense of purpose known by few. Like finding water on the moon.